While you're watching this, something is hurtling past our sun that almost nobody on Earth is talking about. A tiny, frozen chunk of another star system. Probably older than our sun. Maybe older than the sun by billions of years. And it's only passing through our neighborhood once. After this, it goes back out into the dark and we won't see it again. Ever. And right now, our most powerful space telescope is staring straight at it, reading its chemistry, uncovering things that scientists on the ground are still scrambling to explain. This is the hidden story of an ancient visitor from another star, a visitor that may have been born long before our world ever was. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you're new here, hit subscribe right now, because what you're about to hear, most people will never know. Let's start with the basics in plain, simple words. Our solar system has one star, 8 planets, a bunch of moons, and countless smaller chunks. Asteroids, comets, and tiny frozen rocks called icy bodies. Every single one of them is bound by the sun's gravity. Every one of them is locked into a loop. The same loop over and over again. As long as nothing throws it, it stays. But every once in a rare while, something shows up that does not belong here at all. Something that came from somewhere else, from a different star system, from far out in the galaxy. And it's only passing through. It swings around our sun, gets tugged a little by our gravity, then slingshots past and keeps going. Out into deep space, gone forever. These rare visitors are called interstellar objects. And in all of recorded human history, we have only confirmed 3 of them. The first one appeared in October of 2017. Astronomers called it Oumuamua, a strange, elongated, tumbling thing that moved through our solar system so fast it could only have come from somewhere else. It barely held any dust. It barely held any gas. It barely behaved like a known comet. And it left so quickly that by the time telescopes were overhauled and trained on it, it was already a faint smudge fading away. The second one came about 2 years later, in 2019. This one was called Borisov. And unlike Oumuamua, this second visitor looked and acted a lot more like a normal comet. It had a clear, fuzzy halo around it, a visible tail. It was outgassing, meaning its frozen surface was warming up and turning directly into gas, streaming into space. That activity gave scientists something to study. They finally had chemistry to read. But even Borisov moved on quickly. By the time the world's best telescopes had fully lined up their best instruments on it, it too was already on its way home, back out into the black. And it left something big missing. Time. Instruments. A clear, detailed chemical fingerprint from something genuinely born in another star system. So when scientists think about interstellar objects, they think about lost chances, about windows that closed too fast, about ancient chemistry that flashed past Earth's orbit and disappeared before anyone could really study it. Until now. On July 1st, 2025, a telescope in a place called Rio Hurtado up in the Chilean desert flagged something strange moving across the sky. That telescope is part of a network called ATLAS. That's the Asteroid Terrestrial Impact Last Alert System, a set of robotic survey telescopes that scan the night sky every clear night, looking for space rocks that could ever get dangerously close to Earth. Most of what ATLAS catches is ordinary, just asteroids orbiting the sun in fairly normal loops, some of them near-Earth asteroids that need tracking in case they wander too close. That's its job. Earth defense, planetary insurance. But on that July night, the software flagged something different. Not just a different rock, different motion, different speed, different path. A faint point of light that was moving across the sky faster than anything that should be bound to our sun. Within days, observatories across the world confirmed it. The math was clear. This object was not in any loop around our sun. It was on a hyperbolic path, a one-and-done trajectory. It came in. It would curve a little as it got near the sun, then it would sail on out of the solar system, never to return. Mach 1 for the stars, truly just passing through. This was the third confirmed interstellar object in recorded history. It was eventually named 3I Atlas. The 3 because it's the third. The I for interstellar, and the Atlas honoring the survey telescope network that caught it first. Right away, something about this new visitor stood out. Its path was the most extreme of the 3. Before we go further, drop a comment right now and tell me where you're watching from. I read every single one. Here's what makes a path extreme in plain terms. When a small body is orbiting the sun on a stable loop, its path is shaped like a slightly squashed circle. Closed, bound, forever. The more stretched and elongated that oval gets, the more it starts to look like a flat, wide oval, almost like a finger sliding past. And the more open and stretched the curve becomes, the less the sun's gravity is really holding onto it. The geometry of an orbit tells the truth about who it belongs to. 3I Atlas had the most stretched shape of any interstellar object ever measured, the most hyperbolic, the most unbound, like throwing a baseball through gravity's grip gently enough that it brushes the sun and keeps going, instead of looping back. And it was fast, faster by a wide margin than either Oumuamua or Borisov. On the day it was spotted, it was already moving through our solar system at more than 200,000 kilometers per hour. The closer it fell toward the sun's gravity, the faster it got. By the time it whipped around for its closest pass, its perihelion, the technical word, it was moving faster than any local comet astronomers had ever watched dive past. But here's the part that made people stop and reread their notes. Based on the speed and direction of the object, astronomers estimate how long it has been drifting through the galaxy since it was kicked out of whatever star system originally birthed it. You can read its motion like footprints through deep time. It's called kinematic age, basically how long this frozen chunk has been tumbling alone through the dark between the stars. The estimates for 3I Atlas went from 3 billion years all the way up to 7 billion years, and at the high end, depending on the model and the team that ran it, as much as 10 or 11 billion years old. For reference, our sun is about 4.5 billion years old. That means it's entirely possible, and a number of teams put the probability at roughly 2/3, that this comet is older than our sun, that it was already drifting through the galaxy before our star ever ignited, before the planets ever built, before Earth was anything more than a swirl of dust. A frozen piece of another solar system, possibly older than ours, just drifted close enough for our telescopes to actually study. If that doesn't stop you in your tracks, I don't know what will. Now here's where the story turns from awe into something genuinely strange. When 3I Atlas kept falling toward the sun, it started to do something no one expected it to do. Quite this, obviously. It woke up. Not necessarily that it had been completely dormant, but as it got closer to the sun's warmth, frozen gases on and near its surface began to sublimate. That's the science word for when ice turns straight from a solid into a gas, skipping the liquid stage. The dry ice fog you see at a Halloween show is the same effect. The gas streamed off the comet and formed a glowing cloud around it called a coma, a fuzzy halo, and trailing behind it, as sunlight pushed the dust away, a long, faint tail. That meant something very important. This thing was alive, in the comet sense. It was releasing its ancient chemistry into space, and our telescopes could read it. That's the kind of chance astronomers wait a lifetime for. Because here's the trick with comets. A quiet, inactive rock doesn't give up its secrets. It just floats there. You can take its picture, but you can't tell what's inside. An active, outgassing comet, by contrast, basically hands its chemistry over. Every gas streaming off it tells a story about what the object is made of, where it formed, and how much cosmic radiation has battered it across billions of years. 3I Atlas. Being old, being active, being big enough to outgas more than the two earlier interstellar visitors, was now the most readable interstellar object humanity had ever laid eyes on. And then the James Webb Space Telescope turned toward it. Let me stop and explain who Webb is, because if you don't know, it's a story worth knowing. The James Webb Space Telescope, or JWST, is the most powerful space telescope we've ever built. It doesn't see light the way our eyes do. It's tuned to infrared, wavelengths longer than red light, the kind of light that gives off heat, the kind of light that pierces dust, the kind of light that, when broken into its separate colors by a spectrograph, becomes a chemical fingerprint of whatever's making it. Every molecule has its own little signature in infrared, and Webb can read it like a barcode. Webb was not designed to chase fast-moving solar system objects. It was designed to stare at distant galaxies, but the team that runs it was willing to push it. They locked Webb onto 3I Atlas in early August 2025. That was the first detailed look, the first clean read, and what came back surprised a lot of people. The comet's chemistry was off, not just slightly off, substantially off. For one, and this is the first big twist of the story, its carbon dioxide to water vapor ratio was dramatic, way higher than the comets we know from our own solar system. The CO2 to water ratio for an ordinary comet in our neighborhood tops out at maybe 3 or 4 to 1. Numbers shift with distance and temperature, but they stay in that neighborhood. 3I Atlas's ratio was off the chart. Astronomers writing in the Astrophysical Journal Letters, lead authored by Martin Cordner and his team, measured a ratio approaching roughly 20 to 1. Carbon dioxide dominating the gas around the object to a degree that no native comet has ever shown. Why does this matter? Comets preserve the chemistry of where they were born. Their ice is condensed out of the disk of gas and dust that surrounded a young star billions of years ago. The temperature of that disk, the abundance of certain molecules, the chemistry of that remote stellar nursery, all of it got frozen into the ice and carried along. So when a comet has 20 times more CO2 relative to water than anything in our solar system, it tells you that 3I Atlas was born in a very different kind of star system, probably colder, probably much farther out from its original star, maybe in the outer regions of something larger and older, or possibly around an entire different class of star, a different kind of chemistry, a different kind of nursery, a different kind of origin, written in cold ice. But that was just the first twist. Here comes the second one. After 3I Atlas swung past the sun in late October 2025, whipping around at perihelion, it started back out into deep space. And that is when, in December of 2025, Webb turned its mid-infrared instrument, called MIRI, onto the comet and stared again. This time the team was looking at a different range of light, and MIRI delivered another first. They detected methane. Methane heads the simplest group of molecules. It's one carbon atom locked to 4 hydrogen atoms, found on Earth in natural gas, found on other planets, found in deep space. But until JWST looked at 3I Atlas in December 2025, it had never been directly measured on an interstellar object. That is, the first genuinely confirmed detection of methane coming from a chunk of matter that was born around another star. That's odd enough. But here's the part that puzzled scientists, and that makes the find so scientifically powerful. Methane is fragile. When raw cosmic radiation, high-energy particles that wash through interstellar space at near light speed, beats down on a surface for billions of years, methane tends to break apart. Its molecules get smashed or rearranged, so the fact that 3I Atlas is putting out a strong methane signal at all means that the methane we're seeing today is not coming from the surface. It's coming from underneath. Skin-deep math? The outer shell got toasted by radiation. The methane we detected had to have been stored inside the comet, buried, sealed, untouched, since before our sun even existed. In simple terms, what Webb just measured wasn't the surface of 3I Atlas. It was ancient, buried ice. Material sealed for billions of years, only now boiling off because the sun warmed the comet enough. Webb wasn't just sniffing a space rock. It was sniffing the inside of an artifact that had been preserved across most of cosmic history. That thought alone should stop anyone in their tracks. We are living through a moment in which we directly read out material that has been untouched, undisturbed, frozen since before our home star was born. That's discovery at a level that, until very recently, was the stuff of science fiction. And then there was chemistry layered on top of the chemistry. Tied to all that carbon dioxide, all that water, all that methane, Webb and complementary observations also caught the unmistakable atomic signature of nickel, the kind of metallic trace that astronomers don't usually see blooming freely in a comet's halo. Small amounts of iron, too. The metals were being released out of 3I Atlas's coma, its gaseous atmosphere, alongside the gas and ice, as if the comet were broadcasting fingerprints of the metals it was born with. That told astronomers something specific about how the comet formed. Probably not in a hot, inner region close to its star. Probably in a colder, calmer place, where heavier metal atoms could be locked into ice and dust together. The simplest interpretation is one that Avi's team and others have floated. 3I Atlas may have condensed out of material, expelled from an old dying class of star called an asymptotic giant branch star, an AGB star for short. These are stars near the end of their lives. They puff out enormous amounts of carbon and nitrogen-rich material into the galaxy. They are stellar factories of the heavier elements. If 3I Atlas was assembled out of AGB stardust, that would explain both the heavy metal trace and the chemistry that doesn't match our own sun's neighborhood. A comet that may have been born from the breath of a dead star. Reading that, I had to put it down and read it again. But the Webb story wasn't the only one. Hubble was watching too. NASA's Hubble Space Telescope turned toward 3I Atlas right after discovery and then again after the perihelion pass. Its job was different from Webb's. Hubble is a visible light telescope. It gives the sharpest possible images. And those images let astronomers measure something Hubble was particularly good at, how big the object really was. Estimating the size of a comet's solid core, its nucleus, is harder than it sounds. Because the glowing coma around the comet is so much brighter than the tiny rocky core inside, the real body is mostly drowned out by its own fog. Astronomers have to model. Combine brightness measurements across different colors, make assumptions about how reflective the surface is, since comets tend to be very dark and sooty, like a charred briquette. Pluck the dim signal of the rock out of the bright cloud of the surrounding gas. Early estimates put the upper range of 3I Atlas's nucleus at about 5.5 kilometers across. The lower bound came in around 320 meters, about 3 or 4 football fields wide. With the most realistic mid-range number, the nucleus is around 2.5 kilometers wide. That's noticeable. That's a real chunk of rock and ice, far larger than Oumuamua and substantially chunkier than Borisov's fuzzy core. A bigger core means more surface area getting warmed by the sun. More warming means more outgassing. More outgassing means a brighter comet, and a louder chemical signal for instruments to lock onto. That, more than anything, is why 3I Atlas became the most readable interstellar object in history. Other instruments joined the party. SphereX, NASA's infrared sky surveyor, took its own look at 3I Atlas in December 2025 and caught signals of dust made of tougher, more heat-resistant material mixed into the coma, plus emissions that added yet more detail to the chemical reading. ALMA, the Atacama. Large millimeter array up in Chile, a network of radio dishes acting together as one giant ear, picked up additional signatures of methanol and hydrogen cyanide in the gas streaming off the comet. Those molecules matter because they're common in cold interstellar gas clouds, and they tend to survive long trips through deep space. Their presence is a fingerprint of chemistry that likely dates back to the very molecular cloud the comet condensed out of. In other words, this comet kept the chemistry of its birth practically intact across more time than our sun has been burning. Now, one more beat before we zoom out, because I want to set something straight. Because 3I Atlas was so weird, fast, ancient, very CO2 rich, no nitral tail as bright as expected, some corners of the internet spun pretty hard. Some voices floated the idea it might be artificial, an alien craft, some kind of probe. That happens every time an interstellar object does anything unexpected. Curiosity is normal. So is wondering. Scientists do not dismiss that wonder. They check it. So they checked. Radio observatories specifically tuned to search for technology, narrowband signals, structured radio patterns, anything that looked constructed rather than natural, pointed at 3I Atlas and listened carefully across a wide range of frequencies. Nothing. Every radio result came back clear. The object showed no signs of artificial transmission, no engine-like glow, no structured pulses, and everything that was measured lined up with how an active natural comet should behave. Outgassing trends consistent with solar heating. Brightness curves consistent with known comet behavior. Chemistry consistent with an ancient icy body that formed far from its star. Strange chemistry, but chemistry nature knows how to make. The natural conclusion. 3I Atlas is genuinely old, genuinely weird, genuinely different, but genuinely natural. A cosmic librarian spying on a different star system, but a natural one. That's the part internet rumors tend to leave out, that the truth, plain and clear, may be stranger than the rumors. A fragment of another solar system that may have formed before our sun ever ignited just handed us the cleanest sample yet of how alien icy bodies are built. We didn't need to invent anything. We just needed to actually read the data. This moment matters for you, even if you never look at a star. Because right now we're watching the third interstellar object to ever pass through our solar system, and within the same week it passed, we had a global network of telescopes, space-based, ground-based, infrared, visible, radio, coordinated to read it from every angle. That hasn't been possible before. The first visitor came in 2017 and caught us off guard. We didn't have the instruments fully ready for it. The second one came and we got a partial read. The third one came, and we had instruments that did not even exist the first time. And we got the most detailed chemistry ever captured from an interstellar object. If hidden stories like this are why you come here, subscribe now, because we are just getting started. Let me pull back for a minute and tell you the bigger picture. There's a deeper reason this kind of discovery shakes things up. Every time we get to read the actual chemistry of matter born around another star, we get to test our assumptions about cosmic life. The building blocks of planets and comets, the dust, the ices, the metals, they're the same everywhere in the galaxy. They're made from the most common atoms in the universe: carbon, hydrogen, oxygen, nitrogen, iron, nickel. If the chemistry lines up, life-friendly molecules could exist in many places. Where the chemistry differs, like 3I Atlas's heavy CO2 bias, we learn how varied those birth environments actually are. And with every interstellar sample, the universe turns out to be more varied than we thought. Each interstellar object we spot also quietly recalibrates the question of how many there are. For years, scientists debated whether these visitors are incredibly rare, almost one-in-a-generation events, or whether space is full of them and we just lack the tools to find them. With the third confirmed object within less than a decade, and detection technology getting better every year, the balance of probabilities is shifting. There's a real chance the galaxy is full of these wanderers, drifting silently past every star most days, completely unnoticed. Some of them may be passing through our solar neighborhood right now, hundreds at a time. We just don't have the eyes to see them all yet. NASA's next-generation survey telescopes, built for exactly that kind of wide-scan duty, will start catching them at much higher rates. The Roman Space Telescope will come online. LSST, the Vera Rubin Observatory, has just started operations in Chile. That telescope scans the whole visible sky every few nights with extraordinary sensitivity. Many astronomers expect it to drive interstellar detection rates through the roof. So 3I Atlas is probably not a once-in-a-lifetime find, probably the third in a long growing list. And there's an emotional beat of this I want you to sit with for a second. This object was probably born in a star system, a neighborhood, that doesn't even exist anymore. Its parent star may have ended its life billions of years before our sun was even born. White dwarf, neutron star, or just scattered dust by now, gone. And yet a piece of it survived, untouched, hurled out into the dark by a gravitational jiggle, then carried alone through the galaxy for billions of years, tumbling silently, cold, patient. And in this narrow slice of cosmic time, a sliver of the universe's life, Earth happened to grow telescopes pointed at the right patch of sky to catch it. We happened to be the ones awake when the stranger passed. We have only had telescopes for about 400 years. We have only had space telescopes for a handful of decades. Out of the multi-billion-year journey of 3i Atlas, we happen to be alive, and looking, and ready during the one brief moment it passed close enough for us to notice. If telescopes had not been invented until a few hundred years from now, this comet would have come and gone, and nobody would ever have known. The timing is unbearably fragile. The timing is everything. The story doesn't stop here. Data is still being pulled apart. New JWST and Hubble observations are still being reduced, peer-reviewed, and written up across teams in the US, the UK, Australia, and across Europe. We will keep hearing more about 3i Atlas as more detailed findings get published, as more of the buried chemistry gets identified, as telescope teams from other countries get their share of the chemical reading. But the core picture is locked in. We have in our hands the chemical fingerprint of a piece of another star system, likely older than our sun, born in a different kind of chemistry, buried in ancient ice for billions of years, surfaced briefly by the warmth of our sun, just long enough for us to read. We did not invent this. We did not guess it. Webb, Hubble, Spherex, ALMA, Atlas, every number comes from a real instrument that you can read about on a real instrument team page. That's the real story. And it's more remarkable than anything invented. Tell me in the comments, what part of this surprised you the most? That the comet may be older than our sun? That the methane was buried for billions of years? That this may have come from a star that no longer exists? I read every comment. Share this with someone who still looks up at the sky and wonders what's really out there. They deserve to hear the truth instead of the rumors. And as always, thank you for exploring the hidden universe with proof.